One of the things that I absolutely love about this book is the fact that, not like school when we learn something, blind of the purpose of learning it, this book will give you a of motivation by telling you the main goal. Like at the very beginning, it mentions that how important it is to learn a algebra language when it comes to real-world applications. So if you want to check it out, link in my bio. Our goal for today is to learn prime factorization, saying that it has a lot of applications in algebra.
Now, before we head to that, we've got to establish some concepts along the way so we can understand the solution and what exactly is the prime factorization. First of all, the first concept we need to know is the prime number. What is it exactly? A prime number is counting number greater than 1 whose only factors are 1 and the number itself. The second definition we need to know is the composite number, which is the exact opposite of the prime number. It's a counting number too, but it's not prime. Composite number is a number who has factors other than 1 and the number itself. To understand exactly what those concepts are, we need a simple example, because we need to understand what the factor is. So let's take the product of 9 and 8, and they're equal to 72. That means that the 9 and 8 are factors to 72, and 72 is a multiple to each one of them. And that's it, simply. Now that we understand what a factor is, a prime number is simply a number that is divisible by 1 and divisible by itself, but not divisible by any other number. Same goes for composite number. It's the exact opposite. So it's divisible by itself, divisible by 1, divisible by another number, whichever it is. As long as it's not 1 or itself, that means it's a composite number. Now let's head to the prime factorization. The prime factorization of a number is the product of prime numbers that are equal to the number that we're talking about. The prime factorization is a way to represent a composite number that's made of the products of multiple prime numbers that don't have any other divisible other than themselves and 1. And this is a way to represent any other number just by using the product. Simple.
To find the prime factorization of any number, all we have to do is follow these simple steps. So simply, step 1 says, find two factors whose product is the given number. Use these numbers to create two branches. For example, let's take number 48. 48 is the product of two factors that are 2 and 24. Now, for step 2, if a factor is prime, that branch is complete. Circle the prime. Step 3, if a factor is not prime, write it as the product of two factors and continue the process. Now, for the final step, step 4, write the composite number as the product of all circle primes. And that's it for today's video. Thank you for watching, and if you're interested, here's a link to my new series.